Now that we know how to simplify radical expressions, we can start to multiply them. Anything that we multiply together has to have the same index, so I can only multiply square roots by square roots and combine them underneath the radical, and cube roots times cube roots, then I can combine those factors and multiply them underneath the radical. Okay, so these first examples here, again, we're using that property. Before, we were taking what we had and splitting up everything that we wanted to take out. Now we're bringing it together under the same radical. So the square root of 2 times square root of 7. They have the same index, meaning they are both square roots. So if those two things, if they have the same index and it's being multiplied, I can bring them together and multiply them under the same radical. Square root of 17 times square root of y. Again, same index, they're both square roots. Things being multiplied, they can be multiplied together underneath the radical. The cube root of 2 times the cube root of 32. 2 times 32 is 64. And then actually in previous videos we've talked about 64. 64 is also a perfect cube because 4 times 4 times 4 would give us 64. So we have to simplify. If we can simplify, we should simplify. Now I've got the fourth root of 6 times 3x squared. So together they'll be the fourth root of 6 times 3 is 18, and there's an x squared there. We have to ask, do we see anything times itself 4 times? That would give me 18. The answer is no. 18 is just 2 times 9 and 3 times 3. There's no quadruplets there. There's nothing times itself 4 times, so there's nothing I can take out of that radical. And then lastly with fractions, same idea. They have the same index. They're being multiplied. We can bring them together under the same radical. And in this case, we're multiplying fractions, which is just straight across the numerator, straight across the denominator. So I end up with the square root of 3y divided by x times 2, which is just the same thing as 2 times x. Nothing divides out there. That is as far as we can go. Alright, now let's get into the kind of the meat of things here, multiplying these radicals together and then really simplifying what we can. On the left-hand side here, I have 2 times the square root of 5x, that whole quantity, times 11 times the square root of 2x. Notice that everything here is multiplication. I have 2 times that square root. These two quantities are being multiplied together. 11 times this other square root. Multiplication is commutative. I can multiply in any order that I want. So we're going to choose to multiply by these coefficients. And by coefficients, in this case, I mean the numbers that are outside of the radical. So they're not underneath the radical, they are outside of the radical. So I have 2 times 11, which is 22. Underneath the radical, I will have 5x times 2x, which is 10x. Or sorry, 10x squared, because of that x times x. I look to see if there's anything I can take out. The 10 is only 2 times 5. No perfect squares there. X squared is a perfect square. I still have this 22, and then the square root of x squared is x. That leaves me with square root of 10 underneath the radical. Next, part B, I have 4 times the square root of 12x times 2 times the square root of 6x. Alright, same thing. This is all multiplication. I can multiply in any order I want. There's no plus and minus here. It's all multiplication. And I'm going to choose to multiply the coefficients, starting with 4 times 2. 4 times 2 is 8. Then I multiply anything that's underneath the radical. So 12x times 6x is going to give us 72x squared. So the square root of 72x squared. Then I need to check to simplify. See if there's anything I can take the square root of. 72, well, we got 72 by multiplying 12 by 6. And 12 is 4 times 3. 4 is 2 times 2. And 6 is 2 times 3. I'm looking for pairs because this is a square root. Square meaning 2. I see a pair of 2's here and a pair of 3's there. So I have the 8 that's already outside the radical. The square root of 2 squared, so take that square root, it's now just a 2. The square root of 3 squared, again take that square root, now that's going to be 3. And then the square root of x squared is x. Anything that's left, I see there's a 2 over here, and no variables, all the variables came out, so only a 2 goes underneath the radical. Now I've got 8 times 2 times 3 times x. 8 times 6 is 48. X square root 2. Go ahead and try the first two on the right hand side because they are both square roots. Part A on the right hand side. 3 times the square root of 15 times 7 times the square root of 35. Individually, I cannot simplify these radicals, right? 15 is 15. It's not a perfect square. It's made up of 3 times 5. There are no perfect squares factors in there. So there's nothing I can do individually. But I have that property that says if I'm multiplying two radicals with the same index, I can multiply their radicands together underneath the radical. I'm going to start with the coefficients though. 3 times 7 would be 21. Underneath the radical, I would have 15 times 35, which is a little bit larger for us. So let's go ahead and get a calculator and do 15 times 35 and get 525. 525. That's pretty large, so I'm going to go ahead and factor it. I can see that 525 ends in a 25. That means that 25 itself will divide into that 21 times. And then I keep factoring. And 21 itself is 3 times 7. 25 is 5 times 5. There's my pair. So I already have the 21 out front from the 3 times the 7. Now I have to bring out also a 5. So 21 times square root of 5 squared is 5. Underneath the radical, I have 3 times 7, which is 21. Lastly, I have to simplify just one little piece. That 21 times 5 is 105. Anything you can simplify, you should be simplifying. Alright, let's look at the next one. I have 4 times the square root of 2y times 3y times the square root of 6y. I can multiply together all the coefficients, the terms that are outside of that radical, because this is all multiply here. So 4 times 3y would be 12y. Multiply the terms together underneath the radical. 2y times 6y would be 12y squared. Y times y is y squared. Then we simplify anything that we can underneath the radical. 12 is the same thing as 4 times 3. 4 is 2 times 2. I'm going to take out those 2's. I already have a 12y times square root of 2 squared is 2. So this pair comes out as a 2. And then the square root of y squared is y. So anything that's left underneath, anything that's left underneath the radical is just that 3. Simplify a little bit further. 12y times 2y is 24y squared times the square root of 3 still. And that should be as far as we can go. Alright, there's a couple more examples here. But now they're not square roots. They're cube roots and fourth roots and fifth roots. So we have to keep that in mind as we're simplifying. We're looking for perfect cubes, or something times itself 4 times, or something times itself 5 times. But as long as they're the same index, we can bring them together underneath the same radical. On this first example, I have 4x squared times 2x squared under a cube root. 4x squared times 2x squared is 8x to the 4th power, right? 2 times 4 is 8. X squared times x squared is x to the 4th. Don't stop there. You have to simplify that radical now. It's a cube root. The cube root of 8 is 2, because 8 is a perfect cube. 2 times 2 times 2 would give me 8. X to the 4th is not a perfect cube. X to the 4th is the same thing as x cubed times 1 more x. Right? So there would be 4 x's here, but we only need perfect cubes, so I need to take that x cubed out. The cube root of x cubed is x. What's left underneath is this lonely x here. And that's as far as we can go. In part D, now we have a fifth root. Okay, so with this one, because 18 and 81 are pretty large numbers, we just have to keep in mind that as we're factoring, whatever number we get, it started from 18 times 81. So you could choose to multiply them together or just leave it as 18 times 81, since we're going to end up factoring it anyway. Alright, let's look at this. We have the fifth root. We're bringing everything together now. I'm going to go ahead and just take that step to multiply these together. 18 times 81 is 1,458. M cubed times m cubed is m to the 6th power. N squared times n cubed is n to the 5th. Right? A base times a base, we add the exponents. Now, that 1,458, I don't have to overthink it. I got that number by multiplying 18 times 81. Sometimes we have the urge to stop there because 81 is a perfect square, but keep in mind, we're not just working with square roots. This is a fifth root. You need to keep factoring. So 81 is 9 times 9. 9 is 3 times 3. And then with the 18, 18 is 2 times 9. And 9 is 3 times 3 again. We are looking for groups of 5 because it's a fifth root. So I have 1, 2, 3, 4, 5 3's. Something times itself 5 times. Same thing with these variables. Something times itself 5 times. The end of the fifth is already a multiple of 5. The m to the sixth is the same thing as m to the fifth times m, right? Multiples of 5. I needed one more because I started with m to the sixth. Now I simplify. The fifth root of 3 to the fifth power is just 3, right? Take all those 3's out when we take the fifth root of it. The fifth root of m to the fifth is just m. I took the fifth power, I took the fifth root, it's just m. Same thing with n. The fifth root of n to the fifth is n. We look at anything that's left over. I had a 2 and a 3, so 2 times 3 is 6. And I also have an m. That should be as far as we can go. We've taken out all the perfect squares for the numbers, all the perfect squares for the fifth powers of the variables. Anything that did not have a fifth power had to stay underneath that radical. Don't forget to write that 5 as part of your final answer. It was a fifth root. It needs to stay there. Go ahead and try the 2 examples on the right-hand side. Part C on the right-hand side. This is a fourth root. So I have the fourth root of 27 times a times b squared times the fourth root of 3 times a cubed times b squared. They both have the same index. It's a fourth root times a fourth root. I can bring them together as a fourth root of all those factors being multiplied together. 27 times 3 is 81. A times a cubed, we add the exponents, get a to the fourth. B squared times b squared, we add the exponents, and we get b to the fourth again. All of these are actually already something times itself 4 times. 81 is 9 times 9, which is 3 times 3. And I see I've got 4 3's. So the fourth root of 81 is 3. The fourth root of a to the fourth is a. The fourth root of b to the fourth is b. There's nothing left under the radical. They were all to the right power, multiples of 4, so we could take the fourth root of them. All right, part D, same idea, only now it's a fifth root. So I'm going to have the fifth root of, I multiply all these together. I'm going to start with 12 times 24, get 288. X to the fourth times x cubed, we add the exponents. 4 plus 3 is 7. Y squared times y to the fourth, would give me y to the sixth. 2 plus 4 is 6. I'm going to factor that 288. Again, I'm not going to overthink it. It was 12 times 24 to start. Factor that. 3 times 4, 2 times 2. 12 is 4 times, 24 is 4 times 6. 4 is 2 times 2, and 6 is 2 times 3. I'm looking for a fifth root, the fifth root of 288. So I need multiples of 5, or 5 of the same factor being multiplied together. 2 times 2 times 2 times 2 is 2 to the fifth power. I have 5 2's there. I can take the fifth root of 2 to the fifth and get 2. As far as the variables go, I have x to the seventh. That's not to the fifth power. It's not a multiple of 5. I have to rewrite it as a multiple of 5. So x to the fifth is the closest multiple of 5. That means that I would have 2 x's left over. So x to the fifth times x squared gives me that x to the 7th I started with. Same thing with the y. It's not a multiple of 5, so I break it up into y to the 5th power times y. Now I've got 6 y's being multiplied together, but I take out all the variables that have an exponent that's a multiple of 5. The 5th root of x to the 5th is just x. So I can simplify that piece. The 5th root of y to the 5th is y. There are some things I couldn't take out of that 5th root, like 3 times 3. That is, there's only 2 3's there. I need 5 to be able to get it out of that radical. So 3 times 3 is 9. We just multiply it back together, stays underneath the radical. I also could not take out an x squared. I only had 2 x's. I could not take out a y because there was only 1. And that's as far as you can go. So you have to pay real close attention to the index. How many of one term do I have to multiply together? So I have to multiply 5 2's together, 5 x's together to be able to take the 5th root. And then make sure in your final answer, because this gets forgotten all the time, to write that index in there. If it was a 5th root to start, it's still 5th root. Don't lose that piece.